very first preliminary calculations clearly showed that a catastrophic event had occurred in Earth's orbit. Some large object or several objects were torn to pieces. Through the combined efforts of Earth's and the Moon's gravity, part of the material
fell onto the Earth and the Moon in the form of sand and clay. Another part partially crashed into the Earth, partially into the Moon, and the third part
was ejected beyond Earth's orbit, and their fragments turned into short-period comets, which, at certain intervals, still return to the point of the explosion.
Hello, this is the channel Era of Disbelief, and I am its author and host, Mikhail Kalmykov. A brief summary of the previous episodes for those who are too lazy to watch, and also to refresh the course of the investigation in your memory, since there are already quite a lot of videos. So, in the first part of the series, The Invisible Apocalypse, we roughly estimated the amount of sand and clay covering the Earth. At this point, we ended up with a sphere-shaped object with a diameter of more than 400 kilometers. Then we calculated the trajectory of 3 or 4 asteroids that may have struck the Earth in the area of the northern and southern polar regions and near the equator in America. All these fragments left deep marks on the surface of the planet. Then we calculated the spread of the shock waves. And somehow on the map, several narrow strips appeared where people could have survived. And strangely enough, they coincide with the places where civilizations originated. We also found confirmation of one of the stages of the Earth's burial in printed publications from the second half of the century. And we modeled the mechanism of this event based on the hypothesis of the breakup of a large object in Earth's orbit. In the series, The Mysterious City and Alexander Makedonsky, we examined some historical episodes that directly hint at a catastrophe and post-catastrophic events. In the series, The Secret of the Second Planet, we substantiated the very possibility of a denser atmosphere on Earth and also came to the conclusion that the catastrophe was of cosmic scale. It affected Venus, Mercury, Mars, and even the legendary Phaethon, about which there will be a separate video. While uncovering the mystery of the Antikythera mechanism, we also encountered indirect evidence of the active covering of the Earth with sand. Finally, in the video Chain Reaction, we saw a real confirmation of this event with our own eyes. We saw several critical dates that coincide with catastrophes on Earth. Now, it is absolutely clear that the 18 comets we examined did not originate somewhere in the depths of space, in the Oort cloud or the Kuiper belt. No, they were born right here, above our heads as a result of a cosmic catastrophe in Earth's orbit. In previous episodes, modeling clearly showed how, over a relatively short period of time by cosmic standards, the Earth could eject fragments of unprocessed asteroids with the help of the Moon. And National Aeronautics and Space Administration's official tool confirmed this assumption just as clearly. Now we can say for sure that catastrophes occurred both in 1812 and in 1816. There were definitely catastrophes in 1724, in 1608, and in 1504, as well as in 1913, and, strangely enough, in 2017. Of course, over the past 150 years, comets have melted significantly. Some have disappeared completely, so now such passages bring us much less destruction. Now, the passage of comets serves only as entertainment for amateur astronomers. Now we laugh at our ancestors who considered the appearance of a comet to be a sign of catastrophe. We no longer associate the current pandemic psychosis with comets. We don't associate the Spanish flu and typhus of 1918 to 1920, the typhus epidemic of 1812, or the plague of the 1720s to 1730s with comets. But maybe the government remembers? Well, whatever. All these dates of catastrophes are secondary. They happen during the mass return of fragments to their place of origin, and with each year the effect of such a mass passage weakens. Moreover, we only considered the mass returns, but there were also single passages, which are no less intriguing. And now it would be interesting to delve deeper into this question. So, with a very high probability, there were many asteroids tumbling in Earth's orbit, each of which met its own fate. Some crashed into the moon, some were torn apart and then fell to Earth as a muddy, dusty rain. Some even fell onto our planet, while others got a powerful kick from the moon, sending them beyond Earth's orbit. In any case, it must have been one of the most powerful events, and it would be interesting to know its date. But how can we do that? The thing is, simply calculating the orbits of comets back in time is not enough for this. For two reasons. The first reason is purely physical. Any object in the solar system is influenced by various forces, and first of all, of course, it's the gravity of other planets. In our case, it's Jupiter. When passing at a close enough distance to it, a comet or asteroid slightly slows down or speeds up. And since this happens at the apogee of the comet's orbit, that is, in the place where its speed is minimal, even the slightest influence at this section, accordingly, affects the opposite section, that is, near Earth's orbit. For example, if Jupiter speeds up or slows down the speed of a comet by even just a few dozen meters per second, its perihelion will shift from its original orbit by thousands or even hundreds of thousands of kilometers. That's exactly what we observe. The traces from the explosion seem to blur in space. Therefore, to calculate the exact dates of catastrophes, you either need to find an object that hasn't been affected by other forces, or a program that takes such shifts into account and rolls them back in the opposite direction. And here we encounter an unexpected and puzzling obstacle. That National Aeronautics and Space Administration tool, which we used for previous calculations and which is considered one of the most authoritative sources, practically all other sources, including Wikipedia, refer to it. This tool sets a barrier at the year 1600. You physically cannot calculate anything for a date earlier than the year 1600. Why? What's the obstacle? Is the program really unable to count further? Nonsense? From a programming point of view, there shouldn't be any limits. There are, of course, more specialized paid programs with extensive databases. However, even they don't provide the full picture. For example, the simulator you already know about does not allow you to enter orbital data with an accuracy of at least 4 decimal places, and this leads to calculation errors. Other databases like OR do not allow you to operate a 3D model of the solar system with sufficient accuracy, as if there really is some kind of barrier. Well, let's use the tools we have and see what happens. One of the most mysterious and at the same time most publicized comets is the comet Trekhd Biella. Let's take a closer look at it now. So, as usual, let's start with the history. The first to discover the comet was Jacques Montaigne on March 8, 1772. The visibility wasn't that great, but still, our meticulous Frenchman somehow managed to spot it and observed it for the following month. 5 days later, on March the 13th, the comet passed at its closest distance to Earth at that time, about 93 million kilometers. That is, it's quite far. That's 0.62 astronomical units. The second discovery of the comet was made 33 years later, also in France by Jean-Louis Pont. This discovery took place on November 10th, 1805, and a month later, on December 9th, the comet approached Earth at a record close distance of 6 million kilometers. The third discovery was made by Wilhelm von Biela another 22 years later on February 27, 1826. It was then, during almost 2.5 months of observations, that the final calculations of its orbit were made. It turned out to be a short-period comet with a rotation period of just over 6.5 years. The closest the comet came to Earth was on April 19th of that same year, at a distance of 0.96 thousandths of an astronomical unit. And at this moment, somehow, questions just start to arise on their own. If the comet returns to the same point in its orbit every 6.5 years, then why has it been observed much less frequently? First, 33 years passed after its discovery, then another 22. During this time, the comet should have passed by 5 times, then another 3, and then another 3. The most logical explanation is that the Earth and Biela's comet were on opposite sides of the Sun at that time. Therefore, first, the distance was too great. Second, the comet itself is not very bright. And third, its already faint glow was outshone by the Sun. Well, something like that. It all seems logical and doesn't raise any contradictions, if not for one thing. In the previous video, we established that this comet was supposed to pass very close to Earth in November of 1812. How did it go unnoticed? Let's find out. The previous information about the history of the comet's discovery is written in Wikipedia. It in turn cites an article on the cometography website by Gary Cronk as its source, which in turn shifts the responsibility for the calculations to an amateur astronomer from Japan named Kazuo Kinoshita, who in turn refers to the original data he received from the Minor Planet Center, which in turn is a partner of National Aeronautics and Space Administration. So, how does it turn out like this? So, we're relying exclusively on the calculations of an unknown amateur astronomer from Japan who doesn't have a photo of himself and whose name was taken from a character in Japanese anime. Well, actually, Kinoshita is a common surname in Japan, kind of like our Ivanov. But what's most interesting is that absolutely all the data on the cometography website was provided exclusively by this Kinoshita. That sounds a bit suspicious. But what about National Aeronautics and Space Administration? And on National Aeronautics and Space Administration's official website, his surname also appears under many of the orbital calculations. So they're working together. Well then, since that's the case, let's compare the orbits, dates, and position of the comet with National Aeronautics and Space Administration's official database. So, the first date is the comet's discovery. A character from a Japanese manga, according to Wikipedia, tells us that on March 13th, 1772, the comet was at a distance of 0.62 astronomical units from Earth. Let's check. No, on that day, it was at 4.5 astronomical units from Earth, which is 7 times farther away. The next date is December 9th, 1805. The distance is 6 million kilometers. Again, no, on that day it was 300 million kilometers away from us, which is 50 times farther. The next date is April 19th, 1826. The distance is about 143 million kilometers. We check with the National Aeronautics and Space Administration database again, and once more, no, it's actually 183 million kilometers. In light of these events, let's take another closer look at the personality of Jacques Lebax-Montagny, who was the first to discover a comet and also discovered Venus's satellites, which later disappeared. Earlier, I wrote that the only mention of him is in the Encyclopedia Britannica, but that's not entirely true. The very first and most complete mention of him is contained in a letter from a certain to the editorial office of the Journal Observatory, dated July 2nd, 1884, in which he mentions all of Montaigne's discoveries, including the satellites of Venus, but insists that the satellites of Venus were simply illusions, seen by both Montaigne and Cassini. In addition, even back then, he says that he tried to find out who Montaigne was, but couldn't find any information about him except for a note in Lalanne's Bibliography of Astronomy on page 477, where it literally says what his name was. Jacques Saint-Bax was born on September 6, 1716 in Narbonne. In his youth, he was a doctrinaire, and then for a long time he languished in Limoges. There is no more information about Montaigne. In this simple way, the question of faith arises before us. We need to decide whom we will believe. To the mysterious amateur astronomer from Japan, who calculated all the historical orbits of all comets and sent them to National Aeronautics and Space Administration, as well as to the Wikipedias of all countries, but about whom there is no information except that he existed, or to the official National Aeronautics and Space Administration tool, well, or we'll have to calculate everything ourselves. Independent calculations are a complicated and lengthy task, so we'll come back to them in other episodes, but for now, let's trust the official National Aeronautics and Space Administration tool. Well, simply because we don't have any other options for now. In any case, Kinoshito himself only calculated the trajectory of Biela's comet for a narrow period from 1806 to 1852. But let's get back to our comet in 1852. Its next appearance was expected, but it never showed up, and no observations were able to detect it. Just like in 1859 and in 1866, but at the end of November 1872, instead of it, a real meteor storm hit the Earth. The number of meteors exceeded 3,000 meteors per hour. And during the next expected passage, in 1885, the storm repeated itself with even greater intensity, up to 15,000 meteors per hour. And the next time was in 1892. Also, instead of the comet, the Earth was hit by a meteor storm of up to 6,000 meteors per hour. In subsequent passes, the strength of the meteor shower decreased to 150 meteors, and then eventually to 0. Everyone says that the comet simply broke apart, but most importantly, it wasn't exactly a comet in the literal sense of the word. Rather, it was a fairly loose clump of matter in which there were no strong bonds between the material. Yes, among other things, there were gases there, but the main part of the comet was still made up of denser, yet loose particles, presumably clay sand. Earlier observations from the 18th and 19th centuries also show its disintegration. The spiral-shaped coma, which was drawn as early as 1846, clearly indicates to us the rapid rotation of the body. Most likely, this fact also contributed to the accelerated breakup of the comet into pieces. By combining all these circumstances together, we get the following characteristic. An object made of loose, clay-like material mixed with gases moves in our solar system on an almost polar orbit, rotating. Almost its entire path, the comet travels beyond the gravitational influence of the planets. The only exceptions are the two extreme points of the orbit, perihelion, the closest point to the Sun, and aphelion, the farthest point of its orbit. Out there, it passes near Jupiter's orbit, which undoubtedly has an influence on it. However, even at its closest approach to Jupiter, the distance between it and the comet is almost half an astronomical unit. It's roughly the distance from Earth to Venus. This tells us two things. First, although Jupiter does influence it, the effect is not very strong. And secondly, since its orbit is not only far away, but also high above the plane of Jupiter's orbit, Jupiter could not possibly be the origin of this comet. It's just a big vacuum cleaner trying to pull in objects that pass nearby. But at the other end of its orbit, at its perihelion, we encounter Earth. Yes, not just Earth, but an exact intersection with Earth's orbit. And what's even more important, this very point in space is also the point where the comet's orbit transitions from the northern hemisphere of the heliosphere to the southern. This clearly indicates that the comet, at least in the form we know it, was formed precisely on Earth's orbit, right on our orbit. Its progenitor was some catastrophic event in the zone of Earth's dominant gravitational influence. That is, somewhere between the Moon and the Earth. It is precisely this fact that made it return here again and again, to the point of its birth. It was precisely because it originated here that the Earth passed through the meteor stream after its disintegration. Now, one more important detail. The comet's orbit lay in that region of space through which the Earth passes in October and November. And besides that, the angle of inclination of its orbit is such that the Earth encounters it in the northern hemisphere. It would seem, what does this have to do with anything? But it was precisely in October to November of the year 1872 that the Earth passed through a swarm of comet fragments, which could have caused massive fires in the northern hemisphere. In particular, the Great Boston Fire, and a year earlier, at the same time, the Great Chicago Fire. An interesting detail that researchers do not always pay attention to. At the same time as the Great Chicago Fire, fires broke out in the forests and prairies of the states of Michigan, Iowa, Wisconsin, Indiana, Illinois, Minnesota, Kansas, and Nebraska. Here is how the chief of the Chicago Fire Brigade, Brand Major Medill, wrote about the Great Chicago Fire. When we received the first report that one of the houses had caught fire, almost immediately, we received news of a fire that had started in St. Paul's Church, which was located 2 miles from the site of the first fire. Then alarm signals started coming in from all different parts of the city, so we didn't even know where to start putting out the fires first. Reports of fires were coming in like an avalanche. It seemed as if hundreds of arsonists were setting buildings on fire simultaneously in different parts of the vast city. Remember the intensity of that stream, 15,000 meteors per hour. And these weren't microscopic meteors, but real meteorites, piercing through houses, heated up to 1,000 degrees. They instantly set fire to everything they touched. 2 great fires in the same month, a year apart in the northern hemisphere, coinciding with the time when Earth crossed the meteor stream left by Biela's comet. A coincidence, stretching the facts. Maybe. Now nothing can be proven since the stream has weakened, and we will never know the truth. Although, we do know that this comet was actively breaking apart, and although it still retained some semblance of integrity before its final disintegration. The meteorite trail could have started forming long before the complete breakup. And it turned out that the last time before its complete breakup, the Biella comet crossed Earth's orbit just 9 days before it, in mid-November of the year 1812. And again we see a mysterious fire, this time in Moscow. The entire city also burned down for completely unknown reasons. Napoleon urgently leaves Moscow and literally flees back to his homeland. But here there's one big inconsistency. Officially, the fire in Moscow started on September 2nd, that is, during the warm season. And Napoleon left it almost 2 months later, on October 21st, and the comet arrived another month after that. It can be assumed that these events are not connected in any way. However, just imagine, first of all, the Grand Army is marching to conquer a great power without preparing for the cold and without having any winter clothing. Is that normal? Was Napoleon really that confident, or was there simply no winter? Secondly, according to history, the fire started on September 2nd and raged fiercely for an entire week. And 2 months later, when Napoleon left the city, it was still smoldering. Question: did Napoleon really live inside a burning city for 2 months? Why did he leave the city right before winter? Why couldn't he just wait out the winter in the warm city? There was nothing to eat, so what did he live on for 2 months inside the burned-out city? And third, almost immediately after Napoleon's retreat, the frost set in. Of course, you can believe the official version, but it seems to me that the fire in Moscow, Napoleon's retreat, and the comet were simply separated in time by the historians themselves. so that there would be no doubts. But just imagine, if there was no winter or if it was very mild, then there would be no need to worry about warm clothing. Suddenly, a meteor shower falls on the city, setting all the houses on fire. At first, they try to put out the fire, but from the experience of the Chicago and Boston fires, we already know that it's useless. The city burns down completely in a few days, and there's nothing left to catch there anymore. And that's exactly why, and maybe also because the comet impact damaged not only Moscow, but also Siberia, Napoleon retreats. And already during the retreat, suddenly the frost hit. Additional information about the onset of the frost and the 3 years without summer can be found in the previous video. So once again, passing through a swarm of fragments, the Earth is engulfed in fires. Perhaps by rewinding time even further, we will find the day and the point when this comet appeared. Let's try. And we get a new, even more interesting date, November 28th to 29th, 1699. It was in this year that we suddenly, and for unknown reasons, started a new calendar from the year 1700. In this year, Biela's comet passed just 1.5 million kilometers from us. That's so close that it can quite reasonably be considered the birthday of the comet. It's quite possible that in reality it was even closer, but it slightly adjusted its orbit under the influence of Jupiter. Or perhaps it was born after the breakup and explosion of another, much larger object in Earth's orbit. However, a strange block on the National Aeronautics and Space Administration website doesn't allow us to trace the time any further. 1,600 years is the limit. Besides that, it turned out that National Aeronautics and Space Administration's own data contradicts the calculations of other astronomers, such as Kazuo Kinoshita, whose detailed information, by the way, is also hidden from almost all sources. To know the truth, we must calculate it ourselves, long and meticulously for each comet separately. You might even have to write your own program or adapt the most suitable one from those that already exist. I can't promise anything, but we will definitely find out the truth. And if you want to help me, you know what to do. Friends, none of us are immune to mistakes. And if you see a flaw in my logic, don't hesitate. Leave your angry comment under the video, clearly, correctly, and without hesitation. To be continued. Subtitles.